Hello developers, let's start developing. Today is the 4th of December, which means that we have the fourth task of Advent of Code in front of us. Let's take a look at it. I'm looking at them together with you, so this is the first time that I see that we're about to find a giant squid. We are almost a mile below the surface of the ocean, see no sunset. Giant squid has attached itself to the side of the submarine. Maybe it wants to play bingo. Okay, that's a giant non sequitur. But okay, we're gonna play bingo with the giant squid. 5 by 5 grid of numbers. Numbers are chosen at random. Chosen random is marked on all boards on which it appears. Number may not appear on all boards. Yeah, that's nice. Board wins. Diagonals don't count. Uh-huh. Bingo subsystem to help passengers pass the time, generates a random order in which to draw numbers and a random set of boards, your puzzle input. So let's take a look. So this is our puzzle input. Let's see the format of the puzzle input. So we have one line of these and then we have a bunch of tickets, so to say. Okay, we have complete knowledge. After the first 5 numbers are drawn, there are no winners, but the boards are marked as follows. So we have 3 boards. Yeah, this one has 11, has 9, has 7, has 5. Yeah, okay. 24 is drawn, and that means that we have a bingo over here. Third board wins because it has the least one complete row or marked column. Dobro, okay. The score of the can go, and the sum of all unmarked numbers on that board. In this case, the sum is 188. Multiply that sum by the number that was just called when the board won, 24, to get the final score. This is gonna be a bit on the boring side. So let's start up our solution. This time I don't have a ready-made, but I will take one from the template and I just rename the file. There are better ways, but this is the one I'm using. So this was a good solution 4. The day index is 4. This one is actually used to get the correct file, and we will need the input file. And for starters, of course, we're gonna put in the example in the file. Yeah, reading this is gonna be a bit of an issue. So what will be the output be of the input processing? So basically, what is our input? So our input, I'm gonna model it using as an interface. So this is a bingo game, and the bingo game has numbers, which is a number array, and it has tickets, which are an array of bingo tickets. And what is a bingo ticket? Well, bingo ticket one simple way to do this would be to say a bingo ticket is a matrix of numbers. But I want this to be a bit more intelligent, maybe. Let's see if we can get that to work. Maybe we need a class here. Let's see. Let's start it this way and we'll see if we get anywhere. So basically what we need to do right now, we need to process the input. And the input has a single line that has a lot of numbers, so let's try that. Yeah, we're gonna read the lines. This is lines. So the first line that are the draws is basically lines of 0, and then we're gonna split it and let's do this. Yeah, so we're not just gonna map it using the number constructor. I prefer this way. So in the draws line we should have these numbers. So right now, after that, we need to parse the tickets, and I'm gonna say that these 6 lines are the tickets. So the ticket starts with an empty line, then we have 5 lines of 5 numbers each. And I'm gonna omit the first line. And I can say, while we have some lines, well, it generated some totally incorrect code, but its heart is in the right place. So while the length of the lines is bigger than 0, where we're gonna skip 1. So we're gonna take lines of 1, lines of 2 until lines of 5. And we will need to split on a space, but what will happen? Another way to look at this is to use a regex, and I've already said that I quite like regexes. So let's do some stupid things. One thing that concerns me that is we can have 1 or 2 spaces here, and splitting and parsing we might get an extra 0 somewhere, and to be honest 0 is a valid number. Yeah, so what we will do here is yeah, let's use a regex. So the regex is, we have a number, more than 1 maybe, and then we have a space, and that is also more than 1, and let's add that we have a beginning and an end of string. So then we have this thing 4 more times, 2 numbers, 3 numbers, 4 numbers, 5 numbers, but no spaces. And then we have the end of line. So let's see if this matches. You can see that it doesn't matches all the numbers, it doesn't match the numbers that are starting with a space, and I can say, well, this maybe has a space in front of it. Yeah, so this is a quick and dirty regex, and right now I can do this and this and this, and this just uses the parentheses to actually extract that data from the regex itself, and you can see that they are right now colored nicely. So for the first match I have these things extracted: 22, 13, 17, 11, 0. Note that these are still strings. We cannot extract a number from a regex. Regex only parses strings. So we will need to use that to parse a regex. and we can say for, come on, from 1 to 5. Yeah, and we're gonna be hard coding that because each ticket is precisely 6 lines long. The first line we are ignoring, and the next 5 lines are the numbers. So that means that, well, oh, let's define our regex. That's a regex, and we're gonna do regex.exec on our lines of index. Yeah, I. We can also use another format, and that is lines.i match regex. And we can always check if we have a match, but on the other hand, if we don't, this is a deal breaker. That means that we are not matching the input correctly. So I will put in this. If we don't have a match, well, we don't have a valid input. But if we do have a match, then we are guaranteed to have some values, and those values in this case are match of 0 is this whole thing, which to be honest we don't really need, but then we have match of 1, match of 2, match of 3, and so on. So we can say and this is a bingo ticket and this is an empty array. Yeah, a single line will be basically this match or our matches are basically this. So we're gonna omit the first number because that's the whole match, and then we're gonna parse all the numbers that are left, and those numbers are basically a ticket line. And ticket dot push ticket line, we're just gonna add the ticket line into the ticket, and we have an empty array for tickets here. And for after we're done with a single ticket, we push the ticket and we omit the next 6 rows. This might even work. And then we return an object when the numbers are draws and the tickets are tickets. Well, if we rename these to numbers, then we will have a better return type. So this means that our input is actually not an array of numbers, but it's a bingo game. And that means that here we will have a bingo game, here we will have a bingo game, and of course in our show input and test methods as well. So far we haven't used the show input method, but we might. So in order to run the fourth one, I will just import it here and set it as the active solution. So this means when I do npm run debug, it will run in debug mode and it will try to run everything and it will execute automatically the show input method. Yeah, so I got our input. So it starts with a 7 and ends with a 1, and these are numbers. Starts with a 7 and ends with a 1. Yeah, and looks okay. So that part looks okay, but does the other part? We have 1, 2, 3 tickets, and each of those tickets has 4 arrays. Well, we're doing something wrong, because each ticket needs to have 5 arrays. Let's see. Yep, from 1 to 5, not from 1 to almost 5. Let's see. Yeah, right now we have 5 of them, but we will need a better input logging so we can see that. So first of all, I will put in the numbers. We will add the tickets, and we will just say total that many tickets present. In this kind of problems, sometimes we will have a problem when the task itself is not that hard, but to ensure that we are getting the data in correctly might be devilish. And I will say just console log the ticket and then console log some dashes so that we know we're done. Let's verify it now. Five, 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 five. Yeah, looks like we have 3 tickets and each ticket has 5 rows of 5 numbers. Seems okay. And so now we will need to actually do the work. And what do we need to do? Well, we will need to have a function that checks if a ticket is a winner. That is kinda obvious. But how do we know if a ticket is a winner? Maybe we will need some extra logic in this. Let's turn this into a class. And let's have a constructor that takes the number arrays, and well, this is a nice idea, has number. So since this won't be like this, because we will need to look through all the rows whether we have the number, so that means if some row includes the number, then we have that number. And that is not interesting. We might need to have a to string, we might need to have a list of drawn numbers. And this should be again a number array. Hits. Let's kind of deconstruct this. We have all the hits that we took, and that's a good thing. And then we will need something like this. Get the remaining numbers. Well, I just love Copilot because this totally makes sense. We flatten all the numbers and we filter them by not being in the hits array. Yeah. Yeah, get hits we don't really need because that's kinda available anyway in the hits array. But what else we will need? We might need to see if we are a winner. So for being a winner, we will need to determine if we have a row that has all the hits. Yep. If we have a row where every row includes n, then return true. And of course, we're returning false. And we will need to add a bit more complicated logic for, yeah, we need one more. A bit more complicated logic for the columns. But yeah, right now I'm gonna cheat a bit, and that is because I already know that the first game should end with the win on a number 3 ticket on a row, not on a column, but on a row. So let's see if this thing actually does something. And this is not gonna work as it is right now, because this is a class. We will have to say ticket is a new bingo ticket with an empty array of numbers. And we will have to say ticket.numbers.push. Yeah, this is dirty. So we are directly injecting numbers into the constructor. There are a few patterns that we can use to avoid this, but in this specific case, because I know that this will be the only thing that constructs a bingo ticket, no, actually, yeah, I'm not gonna do that. I will do this and this, and we will create the bingo ticket right over here, because ticket is a array of numbers. And tickets is a bingo ticket array. We want to be sure of that. Let's run this one more time, and I think we will have a few problems now. No, actually it looks okay. but you can see that we are displaying this as a class. One thing that we can do is remove numbers as they are drawn. That strikes me as an interesting idea, but I don't know if it will be smart or not. Let's leave it for later. For now, this will be very inefficient because we are recalculating each time. But we'll see. It might be fine. So our logic will be while input dot tickets dot we will have a variable like this. Let's call it winner, which can be a bingo ticket or null, and yeah, which will be, this is a shorter way to say the same thing basically. Yeah, so we're gonna say we don't have a winner. Well, we don't have a winner. JDoc type. I have no idea what this is complaining about. Let's see if this is okay. If I say undefined instead of, yeah, let's have it in the long format. That works. Well, we don't have a winner. Well, draw a number. Input.numbers.pop, but the thing is that input.numbers.pop will destroy our input, and we might want to hold on to that for now. So we want to take the first number, but we will make a copy of the numbers. So we will draw from the draws. And we don't want pop, we want shift. Yeah, we are removing the first element from the array and moving everything to the next direction. So we need to run all the tickets and for each ticket we have a has number. Yeah, we have a has number. Get a hit. And that's all there is. And we can just say if the ticket is a winner, then winner equals ticket, and yeah, break everything. And log the winner. Let's see if this does anything. This, I think that this might go into an infinite loop. No, actually it finished. And we have a winner. Our winner is 14, 21, 17, 24, 4. Yep. And we have the hits 7, 4, 9. 7, 4, 9. We have 12 hits, so to say. 5, 6, 7, 8, 9, 10, 11, 12. 5, 6, 7, 9, 10, 11, 12. Yeah. Cool. Let's see if we have a result from this. Sum of all unmarked numbers are the remaining ones. And we will need to access the last drawn number. Actually, we can do that. These are the remainders, and this is their sum. And we will need to find that sum, and should be 188. Multiply that sum by the number that was just called, and that is the last winner.hits.pop. And let's see those two. And let's try to return the remainders times called. If we're lucky, we might get a result. One 8824 result part 1 is 4512. Yay! This is great. So now we only need to implement the huge to-do we have left. So the algorithm kind of works, and this means that we need to determine if we have a GitHub Copilot is extremely smart or extremely stupid. In this case, it's extremely stupid. So we need to figure out if we have a hit in every row. So that means that we will need to somehow, let's not be smart, and let's do something like this. A for loop. Yeah, well, we know our length. It's always 5. And we can say our element. So we don't want to go this way. Numbers of. We need to want to go by column. And then for each column, we want to see, yeah, this. Something like this. So a column, we are basically mapping the numbers from each row. We are only taking that index, and we have an array of numbers that is literally the column. And now it's simple. If every part of that column is included in the hits, return true, and if we don't have a hit on the rows and we don't have a hit on the columns, then we're returning false, and that's it. Let's try to run this in a non-debug scenario. So far we have a lot more code for this situation than we used to have for the previous three. This one is the first, maybe not too hard, but kind of tedious part of the advent of code this year. But let's see if this actually does anything with the huge input when we have, well, 600, 100, I guess, tickets. And I have a feeling that the process for the second one will be even more complicated. It says that the result for part 1 is 44088. Let's see if that is correct. What do you know? That's the right answer. One gold star closer to finding the display key. Let's see the second part. On the other hand, it might be wise to try a different strategy. Let the giant squid win. Well, it is a bit of a cowardly, but you can't go wrong with that. You want to show how many bingo boards giant squid could play at once. Figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. The second board. Oh. Uh-huh. So we need to see which one board will win last. Let's model this one out on Excel. To make sure that we are getting this correctly. We'll need to paste in something else first, and right now I have a lot of numbers. Let's see, text to columns, delimited on space. That's no, and this is stupid. This doesn't really work, but 3, 15, 0 to 22 and 5 more, but now we will need to fix them a bit. These 4 are here, this is here, and this is here. And of course we have to do the same with these 2 rows. You come here, you come here, here, and let's simulate the bingo. So we are drawing the letters. So we are drawing 7. Let's see. I will just remove the numbers. We are drawing 4. Remove this. We don't have 4. 4. We are drawing 9, then 5. Well, this is 9, this is 5, this is 9, this is 5, this is 9, this is 5. Okay? We are drawing 11 and then 17. 17, 11, 17, 11, 17, 11. 23, 2 and 0. 23, 2, 0. Let's add some borders so we can have this look better. Where were the borders? Oh, here. Thick outside borders. Yeah, nothing like. So, 23, 2 and 0. So 1, 2, 1, 0. 23, gone. 23, 2 and 0. We're drawing 14 and 21 and 24. 14 and 21 and 24. So this one is living on this. 14, 21, 24. And here we have a winner. So this is not the one we're looking for. So next we're drawing the 10. 10 and 10. Okay. And next we're drawing 16. And this one as well. So this, yeah, 16. So at this moment we know that that thing wins. But we don't know when. And then after the 16 we draw 13, and this is a winner as well. And we drew 13, and then we have the sum of these things, which is 148, and then we will need to multiply it, 1924. Yeah, okay, that's cool. So I think that this was a bit of a problem to understand, because we are not really looking for the winner, we're looking for basically the loser. And one of the problems is well, we are running the hits here, yeah. I will add a method here which will be called reset, and that method will just say, yeah, will reset the hits. Why do I need this method? Because here actually, when we are doing something with our bingo tickets, we are modifying them, and if we are not careful, once they are modified, we will just continue modifying them, and that is so. The problem is that in the part 2 we won't be able to count on that our input is not is the okay one, is the has the correct values, because that's the problem with objects, that if you change them and then pass them along, you're passing along the changed value. So I will just say here tickets, input tickets slice dot for of ticket of tickets ticket dot reset. Yeah, so now we know that it doesn't matter in which order we run the part 1 and part 2, we know that we have our tickets set up. Let's run this again to see that we didn't break the first part. Yeah, that is okay. Let's go back to the small input, and now from what I see, part 2 is literally extremely similar to part 1. There are just a few differences that we will need to think about. So we don't have this break. If we have a winner, well, we have tickets. Basically, we need to run. As they are winning, we need to remove them. So, draw a number for each ticket. If ticket has the number, push it as a ticket. If it's a winner, remove it. And actually, I have an idea. No, that's the wrong one. But that might help. So we have a winner, and the winner will be null at first. And if the ticket is a winner, well, winner equals to that ticket, and tickets dot remove that thing. So now we have less and less tickets each time, and each time some ticket wins, we are setting it to be the winner, and we're continuing removing it. So the last thing that we remove from the list is the one that we're looking for. Let's see if this makes sense. 1, 2, 7, 2, which is kinda not what we were looking for. Let's take a look at what we have. Now this will just write object. We need to log it like this. Basically, we need to see this situation. And we have that our winner is 315. Yep. We have a hit on the 13, and then we have a hit on the 6, and then we have a hit on the 15, and then we have a hit on the 25, and then we have a hit on the 12, and I have no idea what we are returning this exact number, but seems that we didn't detect that 13 is a victory condition. So let's debug this thing. Oh, not here. You need to go. So now we are drawing 13. Let's see what our numbers are, because if I'm correct, this should run only once for our second thing. And yeah, that is okay. And we have our hits array. Our hits array. Yeah, we are drawing the 13. So now let's see if we are determining if this is a winner. Let's see the hits array. The hits array should include 13 right now. Do we have a complete row? No, we don't. That's okay. Do we have a complete column? Let's see, the first column should be 3, 9, 19, 20, 14. And this is false. The second column is 15, 18, 8, and so on. And the third column, the column that is interesting for us, is 0, 13, 7, 10, 16. 0, 13, 7, 10. Why don't we have a 16? Do we have a 16 here? Yep, we do have a 16 here. Let's take a look at the data. Yeah, this definitely looks like a 16. And are we drawing a 16 somewhere? Yes, just before the 13th. So we have 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14. This is the 15th number that we're drawing. And our hits array has 14, 21, 24, 10, and then 13. Let's see what our bingo ticket actually is, not the numbers. So seems that we did something wrong somewhere. Let's take a look one more time. 10, 16, 13. Let's write some code. Yeah, let's write that. Actually, that's just a fancy method I have, but let's just use console logs. They are simpler. Let's see which numbers we are drawing. Let's see. Drawing 7, marking 7, drawing 4, marking 4, drawing so on. We have a winner, so that goes away. 10, 16, that goes away. Drawing 13, marking 16. Drawing 16, marking 16. We are only marking a single 16. Why aren't we marking the 16 on the second one? Because we are stupid. This break should not break the loop execution. This actually breaks the loop. So if we are when we are marking it on the first ticket, we are not marking it on the second ticket, and then that ticket counts that it still has a 16 here. So that only when this thing goes or something else goes, only then we have a situation. Let's run the code now. Yeah, this was just a copy-paste error because, well, somebody forgot to think about what he's pasting. Well, that happens. It's not that it won't happen, the problem is that we will need to know what it is. So right now it still says that it has a huge amount of values, and we are getting 1272, and let's see what happens. Until the winner it's okay. So drawing 10, marking 10, drawing 16, marking 16, we have a winner. We should have a marking 16 once more. Yep, this is a bit of a bigger problem because for of is actually a fancy way of iterating through the items, but it still is in essence a for loop. So what we're doing, we have an array from with elements. Let's say we have this element 1 2 3 4 5 6 7 8, and we're on this element. No, I don't want to write a formula. And that means that we have an index, and that index is 2. So let's say that we want to, I don't know, remove the numbers divisible by 3 and I don't know, color the even numbers in a green color. So is this divisible by 2, by 1? No, it's by 3 it's not. Okay, moving on to the next one. Is this divisible by 3? It's not. Is it even? Yes, it is. Coloring it. Is this thing, so increasing the index, it goes to t, to index number 2, element number 3. Is this divisible by 3? Is this thing even? No, it's not. Is it divisible by 3? Yes, it is. Let's remove it. And when we remove it, we are doing this. Okay, we're moving on to the next element. Not divisible by 3, not even. Divisible by 3 and even, so we're gonna remove it. And we're going on to this element. It's even, we will color it. And can you notice what happened? We never processed the number 4 or the number 7, because once we removed that item, we actually skipped that index. So in order to not do that, I will remove this 4 off and change it with a regular 4 that has an index. So it will be less than tickets.length. Ticket is ticket of index. If it has the number, yeah, we're logging it, we're marking it. And if we are doing a splice, this will add 1 to the index. So this means that we will need to remove 1 from the index. So what we will do in our case here, undo. Yeah, is when we remove the 3 and push everything up, we are actually putting the pointer back 1 step, and then the for loop finishes and it goes forward 1 step. So we will process the for 1 more time. There are better ways to do that, to do this, but I kind of painted myself into a corner. So most likely after I'm done with this task, I will try to make it in some kind of a better way. And now we can see that when we're doing marking 16, we have a winner, and then we are marking the 16 on the other thing. We're drawing 13, marking 13, we have a winner, and this is our last winner. The number is correct. Now we will remove all the logging information that we don't need anymore. Let's see if we have some more. Yeah, this is okay, it's okay, it's okay, it's okay. Yeah, we don't have any annoying consoles. Let's run it properly. So this kind of works, but it is a bit on the convoluted side. Let's change this with the huge number, the huge input, and let's see if this works. So the last winner will have a value of 23,670. Let's see if that is okay. Victory! We have 8 stars, and this is cool. But once again, I don't think I'm happy with how my code turned out. Especially this whole force and this. We had to use too many tricks. All of them are operational, all of them are working, but I just don't feel that it's okay. Maybe since we already have a class, we can add a boolean here. So we're not only returning true, and we can just say yeah. Yeah, we can add if this dot one, then just return false. True, actually. If you have already won, you have already won. No need to check anything. And of course, yeah, since it will be read-write, we can directly write it from outside, and we can do for part 2. Yeah. We will need to change it a bit so that we don't have to remove items. On the other hand, I like the solution with removing items because we are not processing, we are processing less and less and less and less data. So it's not that we have the huge bulk of the data because we are winning it out. We could say for example, 1 equals true, and we can have something like if ticket continue with the for, but then this will be incorrect. We will need to have something like let win count, and that's 0 from here, and we will have that win count should be different from the length of the tickets. When the win count will count how many tickets have won. If all the tickets have won, then we're done. And then we can return this to the for of, which I like way too much, because usually for of means that you don't have to think about the ordering or anything, except like in our cases when you actually do need to think about that. So we are not doing anything with the ticket, we are not splicing anything. If ticket has that number, add it. If it's a winner, it won, set it as the current winner, and that's all there is. We don't even actually need the winner because we can basically set ordering to the tickets so that we can just get the one that won last, but this already works, so let's not make any problems. Let's see if we have the same value right now. So I'm still not happy with this code. And I'm definitely not happy with this specific code, because this specific code run into an endless loop, because if a ticket has won, we will need to increase the win count by 1. Yeah, and I sometimes, just to be fancy, use this format. This means decrease it by -1, which actually turns out to increase it by 1. Let's see. 2367. Yep, this one is correct, and it is a little bit better. Too weird for my taste still. There might be a better way to do this, but let's see. Yeah. For now, that will be it. I will be signing off. This is the first time that I actually used interfaces and classes. This is basically the worst class ever because it has public properties that we are accessing directly, and we are not supposed to do that. We are doing a lots of recalculation, a lot of this can be cached, and let's just see how fast this thing is when run from the command prompt without the debugger, without anything. So 19 milliseconds, 31 milliseconds. That is still relatively fast, but I would say that for a real scenario this would be unacceptable. So I will try to optimize it and have it run better, because we won't need to recalculate all of this all the time. We might need to basically use some memory to have the numbers mapped better, or maybe have some kind of a hash set of the numbers so that we can fast and get which numbers are missing, which numbers are hit in a much more linear way, not passing through the data all the time. But this is a nice first approximation of a working solution, and that's what I'm trying to do. It's better to have a slow working solution than not to have a working solution, because right now when we have a working solution we can think about it and we can tinker it and we can optimize it, but don't try to go straight to the most optimized code, because then you don't know what the problem is. You don't know if you have the correct thinking of the problem, and you don't know if you have a solution. So that's why I stuck with my weird for off thingy until I got to the solution, and only then I said, okay, now I think I can make this a little bit better. So with that, I will be leaving you, and as usual, if you want to learn about classes and interfaces, there's a whole chapter of that in the TypeScript workshop. Feel free to check it out. As you know, I'm biased, that's my name on there, but I still think it's a good book. Thank you, and see you tomorrow.